Good morning. I will introduce you a product called Portable Hardness Tester, DPM3. Our team is composed by myself, Albert, Mr. Rogério right here, and our advisor, Dr. Adriano Ballarin. A hardness is considered to be one of the most important surface properties of the flooring materials, and also a meaningful quality indicator for wood. A hardness tester, as its name implies, is a device able to evaluate the hardness of materials. The DPM3 was designed to meet the demand for wood quality control under field conditions. We selected the railway companies because the DPM3 was conceived since the beginning of the research driven and based on this specific market demand. The Brazilian railways are composed of 20,000 kilometers using wooden sleepers. 900,000 units of sleepers are replaced annually. This market turnover is almost $14 million per year. The programs for sleepers replacement are the most expensive activity of the railway companies. The problem is the current way for rating the sleeper's quality has been unreliable because its criteria is normally based just on visual aspects and visual inspection. These companies purchase a large amount of wood and crave a reliable and righteous classification under field conditions. The lack of effective quality control implies no price differentiation between high and low performance elements. And also, the low performance elements can't be properly distributed along the railway. A low performance element wrongly rated as high performance will be overvalued and will increase the future costs of maintenance. The sleeper's quality has also implication on the railway safety conditions. The DPM3 will enable the effective quality control, shifting the visual way for rating the quality to a formal and parametric process. Here we have a cost reduction assumption, just for instance, in a $14 million per year market, assuming that 30% of the sleepers are low performance elements, and you can get 10% rebate based on the formal inspection, on the formal rating. Then it will be possible to save $1.2 million per year. The DPM3 allows 100% sampling due to its quick methodology, and also a suitable distribution of the sleepers along the railway. Currently, there are no devices, both handy, automated, portable and automated, for wood. There is no device today. The laboratory testers, despite being accurate and automated, they are non-portable, expensive and heavy. They can easily reach 100 kilos and dozens, thousands of dollars. Well, the hardness of the wood expresses their resistance to the indentation of a body. In a typical test, a spherical indenter will be pressed against the material with a calibrated force, promoting a small sinking, normally called indentation. After the removal of the force, the hardness will be calculated based on the dimension of that sinking. The current portable testers use magnifiers in order to perform the visual readings of the indentation. Of course, the hardness value in these equipments is achieved through calculation. Another negative aspect is the employment of shear pins to calibrate the force. which imposes a cost of 40 cents of dollar per test. Beyond that, the indentation readings are made after the removal of the force. It's a problem because after that instance, the resilient effect of the wood will recover a portion of the indentation. Now we will show the DPM3 working. Please, can you say start strongly?
Stop.
Stop. It's the time to make a test. After this quick impact, the DPM3 recorded 8,000 values of the event, read the indentation, and calculated the hardness of the material, showing it in an electronic display. Furthermore, all data could be transferred to a mobile device, as a cell phone, for instance. Thus, our idea is a simple equipment that offers portability, user-friendly, automated, and accurate measurements. The indentation readings are made under load, avoiding the influence of the resilient effect of the wood. And even more, the DPM3 has wireless communication that allows the automated production of field reports. It is an innovative methodology. A traditional hardness test spends at least 6 seconds. On the other hand, the DPM3 can perform the same test spending just 5 seconds, including data transfer. It is a reliable methodology. In this graph, we have a correlation between the DPM3 values and hardness values taken using a sophisticated lab machine. We have a correlation 0.9. It is a very nice value for wood. It is a recognized methodology presented and proofed in many conferences, both in Brazil and abroad. Our signal has potential because the DPM3 computes the hardness based on the indentation contained in the first impact of the test. But the completely signal has potential to express another important properties of the wood. For example, the elasticity module. So we has potential to check the hardness in the elasticity module also. The DPM3 can be used in every market with demand for wood quality control under field condition, as parquet flooring, sawmills, building supply stores, and wood quality laboratories. It is our product roadmap. We are placed in the red market and working on design improvement. For the railway companies, the design improvement is the last step in order to achieve the final product. But for business expansion, tests on new wood species are also needed. We have national and international patents pending. Thank you.